Hello and welcome to another Algebra 1 video tutorial. In Lesson 12.2 we'll be completing the square. Our goal will be to use completing the square as a method for converting a quadratic expression in standard form to vertex form. So once again, completing the square is a process that converts an equation for a parabola from standard form into vertex form. So you remember standard form from chapter 9 of a quadratic. And vertex form, you just learned last lesson, is y minus k equals a times the quantity x minus h quantity squared, where once again remember the vertex is at h comma k. So today we're going to go from standard form to vertex form, and we'll learn a method called completing the square. Alright, complete the square on x squared plus 6x. With algebra tiles, here's what it would look like. You have x squared and 6x's. Now it's hard to make a square like that, so what the first thing you'd have to do is rearrange them a little bit and take half of your x terms and put them go on each side. So we'd end up with x plus 3 on one side, x plus 3 on the other side. So what would it take to complete the square? Well, we'd fill in the missing part of the square. And we'd extend these down because they're each ones. Extend this one down, they're each ones. So what would be adding is there's one there, one there, one there, one there, one there, one there, one there. We'd be adding 9. So to complete this square, we would need to add 9. Now that's a perfect square because it is x plus 3, the quantity squared, which is x squared plus 6x plus 9. So we need to add 9 to make that a complete square. So to complete the square on something in the form of x squared plus some coefficient x, bx, you'd add half of b, right? Because you'd need to take half of these and go on one side and go on the other side, go in length and width, and square it. That's what it need to be. So visually, you take half the b terms, put them here, half the b terms, put them on the other dimension, and this part would be a half b times a half b, which is quantity 1/2 b squared. Alright, so we'll use this to convert this equation to vertex form, and then we'll say what's the vertex. Okay, so we have y equals x squared plus 4x plus 18. Right, the way this is, it's not a perfect square. So what would make it a perfect square? Well, we want to isolate x squared plus 4x. So let's subtract 18 from both sides. So y minus 18. I will leave a little room here because we're going to add something to both sides. So equals x squared plus 4x plus something, and we're going to add that plus something in here. Well, what is it? Well, we need to take half of this term, so we need to take half of 4 and then square. So this would be 2 squared, which is 4. So we need to add 4 to both sides. So this becomes y minus 14 equals, now we can make this look like a square of a binomial because it's a perfect square. We'll make it x plus, it was this term here, half of 4, which is 2, so x plus 2, the quantity squared. And if you expanded this out, you'd end up with x squared plus 4x plus 4. So this is in vertex form. The a value here is 1. So the vertex now we can say is, well, normally this would have been x minus negative 2, so the x corner of the vertex is negative 2 and 14. Negative 2, 14 would be the vertex. Alright, convert the equation to vertex form. What is the vertex? Okay, so this is not a perfect square the way it sits. 30 is not the term we want there, so let's subtract this. It'll be y minus 30 plus, let's leave a little space. Okay, x squared plus 10x plus what makes this a perfect square? Well, we take half of 10 and square it. So half of 10 is 5. 5 squared is 25. So we need to add 25 to both sides. So we needed 25 here, not 30. So this would have been y minus 5 equals the quantity x plus 5 squared. So it was half of 10. So x plus 5, which is the trinomial x squared plus 10x plus 25, but we want to make this vertex form as a perfect square, so the square of a binomial needs to be on the right side. So now, what is the vertex? The vertex is negative 5, 5. This would be x minus negative 5, and y minus 5, so 5. And that's the vertex. Alright, number 3. So if we do enough of these, we get the hang of it, hopefully. Now, in this case, this one is already a perfect square the way it sits, so we don't have to subtract 25 and then add 25 back in, because half of 10 is 5. 5 squared is 25. So this is already a perfect square. So y equals the binomial x plus 5, the quantity squared. So that's already, this 25 is what we did want there. That makes this is already a perfect square. So we could think of this as y minus 0. So the y coordinate of the vertex is 0. And x minus negative 5, which we see as x plus 5. So the vertex is negative 5, 0. All right. Convert the equation to vertex form. What is the vertex? Okay. Now, so instead of subtracting 52, let me show you another way here. Let's think about, all right, what's half of 14? So half of 14 and squared, so that's 7 squared is 49. So we need this to be 49 instead of 52. So we have an extra 3. So all I'm going to do is subtract 3 from both sides. So I'm going to get y minus 3 equals x squared plus 14x plus 49. This is a perfect square because I knew I needed 49 there. So this is going to be the quantity x plus 7, quantity squared, y minus 3. So then the vertex is negative 7, 3. All right, convert this one to vertex form. So we don't have anything we need to add or subtract. This is already isolated, but this is a negative 10. Okay, so we were just going to add something to both sides. X squared minus 10x plus what? Well, we take half of negative 10 and square it. So negative 5 squared is 25. So I get y plus 25 equals x. Now this is a minus, so this is a negative 10. So this is a minus. Half of negative 10 is 5, so x minus 5, quantity squared. So the vertex in this case is 5, negative 25. Okay, convert this equation to vertex form. And this is the most difficult one because notice this term right here is not 1. And everything we've done so far has been 1 there. This is a negative 16. We have to kind of remove that negative 16 first. And how do we do that? Well, we just divide both sides by negative 16. Now first what I might do to make this easier, instead of height and time, let's put this back to y equals negative 16x squared plus 32x plus 6. Not that it matters, but maybe it's easier for you to work with y's and x's. So the first thing I'm going to do is divide everything by negative 16. So y divided by negative 16 equals x squared. 32 divided by negative 16 is negative 2, so minus 2x. And then a 6 divided by negative 16 is going to be a minus 3/8. Minus 3/8. Okay, now, is the minus 3/8 what we want there? No, it would have to be a positive anyways, because to make this a perfect square. So the first thing we're going to do now is isolate x squared minus 2x. So add 3/8 to both sides. So I end up with y over negative 16 plus 3/8 plus something equals x squared minus 2x plus something. Well, we take half of negative 2 and square it. So negative 1 squared is 1. So we're going to add 1 to both sides. In this case, I'm going to add 8/8. Okay, so I end up with y over negative 16 plus 11/8 equals what binomial squared? X minus 1. That's what x squared minus 2x plus 1 would be. That's a perfect square. Square of a binomial. Now, this is where I need to get this back to y equals, or not y divided by negative 16 anyways. So I'm going to multiply both sides by negative 16. And I'm just going to leave this in vertex form on the right side. So I'm going to get negative 16 times the quantity x minus 1 squared. Now distribute here, I get y. Distribute here, I get a negative 2 times 11, so minus 22. What is the vertex? The vertex is 1 and 22. So this would have been a parabola. So height and time of a quadratic from chapter 9. So it started from a height of 6, goes up, comes down. We got this highest point there is going to occur at 1 second and 22 probably feet. So the vertex is 1, 22, but notice the process of getting it to get rid of this coefficient of, make this a coefficient of 1 so that we can complete the square. Because if you don't have that coefficient of 1, you cannot complete the square. Then at the end we'll convert it back to where that negative 16 is where it belongs. So the a value is negative 16, which means the parabola opens down. All right, that's a lot thrown at you, but if you break it down piece by piece, not too bad. Your assignment will be 12-2, page 726, 2 through 24 evens. Thanks for tuning in, and we'll see you next time.